Thank you very much, everyone. So first of all, this is my first time attending a ROCCO event. So I feel that I've been put on the spot, and maybe literally, actually. And to add to my burden, I have the last session before the lunch break. So I hear that everyone in his mind, is it chicken or fish that I should take? So I'll try to make it quick. I'll try to make it interesting and just worth the 15 minutes of your time. So is AI in fraud management really real? This is the title of the presentation. First of all, about myself, my name is Ihab. I've been in the telecommunication industry since 2001. And during this 21, 22 years, I think I split it equally between MNOs, MVNOs, and vendors. And I think it's really interesting when you see the story from different perspectives. You look at the same thing through different lenses, and it gives you a different perspective into what's happening. About my company is LATRO. And LATRO is a US company with a headquarters in Pennsylvania, US. We have been incepted, I think, so we have customers of around 60 plus operators, regulators around the globe, and we have 20 plus nationalities in our team, so we are a diverse company. About our history, so we started in 2010 with a bypass fraud. So we were the guys who were actually known for busting SIM boxes. We were busting SIM boxes and doing all of these things. Then we moved into more of a general RAFM solution where we are providing complete suite of revenue assurance fraud management for our customers. And we are moving into more of a managed services. And I've heard that even during today's sessions, how managed services is actually being talked about in the industry. So we have some good customers on the RAFM and charging managed services. And finally, we're working on a more general data analytics and data intelligence. So, AI, we've heard it multiple times during those presentations and during those discussions. But what is it exactly? What do we mean by AI? So if we look at artificial intelligence as a word, it is actually a software that is imitating a human mind, that the software is trying to do planning, learning, and other things. And we always couple it with machine learning or ML. And ML here is just a subfield of the AI, where actually the mathematical models are actually developed in order to use data to provide answers for the questions. Cool. Machine learning, and then we're talking about a lot of things. I don't want to turn this into a lecture, but it is good just to understand the types of it. So we have two big types, which is supervised learning and unsupervised learning. So in the supervised learning, it is like an algorithm that needs to get some label data or training data that will actually use it in order to understand what happens, then applies what it learned through this data to the other set of data, and then give the results. We call it supervised learning. While in the unsupervised learning is that you just throw the data to the model and you expect something that will come out. Cool. So what can AI/ML offer to fraud management? And we are just focusing on fraud management for this session. And why we're asking this? If you are as old as I am in the telecom industry, I remember back in 2006 where big data was actually the big topic. And every presentation you got with every vendor, they will talk about big data, big data, big data. We were under the impression that after a week or two, I will come to my office and all my systems are suddenly changed to have big data. But now, after 17 years, we still have systems that are running SQL-based databases in our systems, and it is working fine. We have other potential that big data opened, and I think that only recently we start seeing that big data is actually changing the market. So we're asking this question, whether is AI/ML a similar thing that we are all expecting that tomorrow all our life will be different because AI/ML? Or is it something that will take time to mature and to start generating actually output? So, to know what AI/ML will do for us, I think we need first to start looking into what we are doing without AI/ML in the fraud management. So in the fraud management, and this is like just some words that I came up with, it's not coming from any scholar or something, so don't put a lot of credit on it. We usually do control testing. So one of the initial things when you do fraud detection is that you try to test it, and you do some tests that you know the output, and if the output is not correct, then there is actually a fraud that could happen here. We also did a lot of behavior analysis, just trying to see how our standard behavior for the customer is doing, and a sudden change in the behavior could be an indicative of a fraud activity. And we established that by using threshold rules. So a customer who's making 40 calls per day, there's a question mark. A customer who's doing 10 transfers, credit transfers per hour, there's a question mark. So those threshold rules are actually some of the legacy flexibilities or some of the legacy controls that we use to detect fraud. And finally, some technical classification. So if I know the type of this device, then I can know that this device is fraudulent. So I can actually detect some technical characteristics of devices, of people, of traffic types that actually could lead and to detect fraud. So let's take some example. And for the example I put here is actually bypass detection. Yes, it is obsolete for some of you. Yes, it is relevant for some of you. But take it and generalize it to any fraud case that you have, being an RSF, being a flash calls, being CLI refiling, being whatever fraud case that you see is actually applicable to it. So for the bypass, we used to do test call generation. And we send a lot of calls, and we look at the termination and see whether this is actually landing through a SymBox or not. But this is actually a control testing. So we know the output, and we are trying to identify fraud using it. A lot of CDR analysis, where actually we look at the CDRs, and then we try to see whether these are generated by a SymBox or not. So this is a behavior analysis with the threshold rules. We at LATRO, we did what we call protocol signature technology, where we identify the device by the fingerprint of its signaling without the IMEI, so how the signaling is behaving. But this is actually a technical characterization. So if you look at any detection that you are trying to do, it falls into those categories before AIML. So if you want to add AIML, what can we do for this fraud detection? We can do anomaly detection, assuming that SymBoxes will have an abnormal behavior compared to the other normal subscribers. So this is anomaly detection, an AIML algorithm that will actually give you anomalies into your data. We can do clustering, and we can say that assuming that all the SymBoxes, they behave the same, if I do clustering, then I can, from the data that I have, see that those are actually fraudulent activities. Again, it is a SymBox or non-SymBox. It's just an example. And third, we can do classification. So classification means that if you know a fraudulent behavior, you can use it to train a model, and the model will give you similar subscribers, customers, whoever, with the same behavior as they are actually fraudulent. But is it the silver bullet? Is AIML the silver bullet? Is it something that if I implement, I will go home, I will sleep my long night without worrying about fraud, without saying that everything is under control? So for what we have discussed, the anomaly detection, for example, it is unsupervised learning, so it is quick to implement because you just implement it and it will scan your data and give you the anomalies. But it gives you like just an initial list, an initial suspect list that has a lot of false positives if you want to consider it as confirmed detections. And you need actually to drill down and see why those anomalies happening, why those customers are behaving in an abnormal way, and then understand whether this is a fraud activity or simply a crazy customer doing something crazy. Clustering is, some really good clustering examples are for marketing segmentations where you actually segment your customer behavior. But segmentations tend to be not very, let's say, efficient when it comes to fraud detection. Classifications are good. So classification, if you get a behavior for a fraudulent activity and you put it on a classification AIML algorithm, then it is good and it will give you some similar activities within the customer. But it is as good as the training data. So you need first to detect some fraud, then use classification in order to detect more fraud. So you're still back to the old school once more. So the simple answer, no, it's not a silver bullet. But is it that bad? So no, it's not that bad. It is a technology that we should adapt, and it is a technology that will open potential for us. It's a technology that will provide suspect list in a very quick way, that you look at your data, and then you see that those are areas that I need to look at. It's a technology that can help you set dynamic thresholds instead of the 30 calls per day. No, it could be 30 calls per day for this guy, but it could be 3 calls per day for the other guy, which is abnormal activity for him. It's very good when it looks at pattern identification. So you can identify the patterns and then highlight where are things that are actually miscellaneous or could be suspicious. It's very good for data correlation. You have a lot of data that you can get, and doing it manually without AI/ML is actually hectic. But adding AI/ML will give you more dimensions to the data that you have, and it will enrich your analysis, and it will give you more visibility on what's happening in your data so that you can do more general data exploration. So we did that in LATRO, and we did a leverage on AI/ML in our sandbox detection by what we did, and we called it the suspect behavior analysis. So we actually teach our models with some training data, and we look at all the data and tell the model, give me where are the spots. And it's pretty quick. It gives you like this clusters of operations or sandboxes or fraudulent activities that are actually happening. So for the sake of time and for the sake of not holding you more about your lunch, I'll just do a conclusion here. So the conclusion is, we all want to do an effective fraud management framework, and this is on the benefit of everyone. But in order to do that, we should start from the base. We shouldn't go from the top. The base is talking about an infrastructure with wide range of data streams, a lot of data that is coming, that is consumed, that is correlated. Oops. And then we need to understand the fraud space and the effective controls. So without this, just assuming that an AI/ML will solve your problem, no, it will not work like that. You need to understand what's happening. You need to understand the fraud that is happening, what is the dynamic, what is the benefits of it for the fraudster, and that's you need to do it. And then you still need to continue relying on some legacy controls. Some legacy controls are effective, will remain effective, and will be even more effective than an AI/ML-driven algorithms. But finally, extend it with AI/ML. It will give you the flexibility, it will give you more features, and it will give you something more than what you already have. I'll skip this. I had some slides for that, but I think my time is off, so thank you very much.